So welcome to today's session on Introduction to Cloud Computing. Today's training instructor is Michael Tang. Michael is the cloud analyst with Advanced Research Computing at UBC. He is also a member of the Digital Research Alliance of Canada's Cloud National Team and the Abutis Cloud Operations National Team. In these roles, Michael manages many of ARC's cloud pilots and supports researchers across Canada in both community and public cloud environments. With that, I'll pass things over to Michael.
Thank you, Tang, and thank you everyone for making the time today for today's Introduction to Cloud Computing training session. So to begin, we'll start with land acknowledgement. So we would like to acknowledge that UBC's Point Grey campus is located on the traditional, ancestral, and unceded territory of the Musqueam people, and UBC Okanagan campus, Kelowna, lies on the unceded territory of the Syilx peoples. For today's training session, we'll have a quick overview of an introduction of what is cloud computing, what is cloud, and then we'll go over the cloud options, cloud resources available to UBC researchers. And during each of these sections, we'll have some breaks, not breaks, but place where I can answer further questions. But as Tang mentioned, feel free to answer your questions in the chat or Q&A, or unmute yourself to ask the questions in real time. And last but not least, we'll also go over a little bit on the privacy and security, things to consider as you're using the cloud. So what is cloud computing? Cloud computing is the on-demand availability of computer system resources. So when you need it, you request for it, and then you have access to it for the duration that you need for whatever workflow that you need it for. Delivers high-level services and access to system resources over the internet. So the idea of the cloud is that everything is not within under your desk or anything that is on premise or on campus. It's somewhere in another data center. Some common services that you may be familiar with that are in the cloud are some collaboration tools, including email, calendars, and web-based file hosting, and like Dropbox, and other resources such as system resources for infrastructure, compute, disk, networking, load balancing, etc. And these services are often categorized in three different types. First is the software as a service. So things as mentioned as like email, Google Docs, virtual desktop, things like that are managed by the service provider and come ready to use. They are the ones that maintain the updates, bug fixes, and overall maintenance. So you don't have to worry anything like that. So for example, like Google Docs, you log in, you use it, you don't need to think about the maintenance aspect of it, security updates, all that. Next, we have the platform as a service, and that is they deliver and manage all the hardware and software resources to develop applications through the cloud. So things like operating networking, operating system updates, and things like that. Last but not least, at the lowest level, is infrastructure as a service. So that provides you access to the compute, storage, networking, and so all the pieces to build the infrastructure that you may need in the cloud. So those are the various categories. We'll go a little in detail, especially the infrastructure as a service, the services that we'll be discussing today. So next, we'll have the concept of a virtual machine. So it's a very common concept that you may come across in the world cloud. A virtual machine is a virtualization or emulation of a computer system. Virtual machines are based on computer architectures and provide the functionality of a physical computer. So instead of having a hard tower under your desk, you have something that's virtualized. So it is still have hardware underneath, but it's been abstracted from you. That's why it's called a virtual machine, and is often discussed or used in the cloud world. Some common use cases include data portals, web applications, larger machines. So if you need larger computer for things that require more memory, things like that. and for testing. So you need to test your workload somewhere else before you scale up to larger resources. So in the ecosystem of cloud for research at UBC, there are three main areas that you can have access to, including the commercial cloud. So that has available globally, including Canada. So there are data centers within Canada, and they offer services in all three categories: software as a service, platform as a service, and infrastructure as a service. So security updates are available depending on which category the service falls under. And there are costs associated with that, and it's pay as you go. So you pay for as much as you use. Next, you have UBC EduCloud. So that's a service that's offered at UBC through the UBC IT. It's located on premise on the Point Grey campus in Vancouver, BC. And they offer as an infrastructure as a service. So they provide you all the pieces like storage, compute, and things like that to build the data portals or virtual machines that you need. And as part of the security updates, there is an automated patching process that's available as of this year. And with that service, there's also a cost available, a cost involved, and we'll discuss it a little bit in the later section. Last but not least, the Alliance Cloud, or Digital Research Alliance of Canada Cloud, is also offered as an infrastructure as a service, and that's the major part of that service. They also have databases as a service and Nextcloud, which falls under the other two categories. The security aspect of things, the updates are your responsibility. So you apply the security updates on a regular, you need to apply them on a regular basis. However, this service is available at no cost to researchers. So the first service that we'll be discussing today is a UBC Hybrid Cloud, which is a service available through UBC IT, and it provides UBC users, researchers, faculty members access to the commercial cloud. They will provide you access to things on Amazon Web Services, AWS, Microsoft Azure, Wasabi Cloud Storage, and soon Google Cloud Platforms, GCP. And so by accessing these cloud providers through the hybrid cloud service, you by default will have access to the guardrails that UBC IT has applied in place to set us in the right position to comply with UBC's information security standards. It also enables you the ability to route your network to IPs in on-premise. So for example, if you need access, if your cloud resources need access to an instrument that's located on campus, this will be very helpful. And last but not least, it uses UBC CWL, which we all have access to authenticate, which helps with the compliance aspect of things. And so some eligibility requirements that with this service includes that UBC faculty members, staff, and research community can request for access. However, student accounts are not eligible. However, if it is a research project, you can add students, graduate students, for example, to these projects. It's just that they can't request for the accounts themselves. It requires an approval from an authorized signatory for financial spend. Signed service level agreement. So that's part of the process is you request for this access, and a primary work tag ID for automated monthly chargeback. So it's all automated in the back end. So you do not need to provide a credit card sign up for these commercial cloud accounts. To request for an account, the request form is on that slide, so you can have access to that link there. And for more information to this service, you can access that link as well at the bottom of the slide. So as we mentioned, it's with the work tag, it's an automated chargeback. So whatever resources you use during the month, you'll charge a certain amount of cost, and you'll be billed automatically to the work tag that you provided when you requested for the account. So it's billed monthly, and then again, no credit card is involved with the transaction. And to help with estimating how much this will cost, there are calculators that are available for the major cloud providers, and those are the links to those calculators to help you get an estimate of how much it would cost to deploy the infrastructure that you need for your research project on any of these cloud providers. Besides charging it to research grants, there are sometimes credit opportunities. So these are credits that are applied to Amazon Web Services or Microsoft Azure or Google Cloud Platform. These are opportunities run by these cloud providers, and often they come with other requirements. However, these do come by from time to time. For example, currently there is an Amazon Research Awards. They have their spring call right now that's open, and it closes on May 6th. It's an opportunity for specific research fields. So if you happen to work in any of these research fields that Amazon has indicated, that this opportunity is open now for you. Through the UBC Hybrid Cloud Service, there are costs involved besides the estimates that the cloud providers charge. There's a brokerage fee of 7.5%, and that began during the fiscal year of 2023, 2024, and that has not changed since. But if it does change, there will be announcements that will be made. So the additional brokerage service fee includes things like the AWS enterprise support that includes 24/7 phone, web, and chat access to cloud support engineers, consultative review and guidance based on your application, and faster response time to tickets. And then Azure has basic support with some similar type of support. And another benefit of using UBC Cloud Services is that when the university as a whole reaches certain thresholds of spending, there are discounts that are provided, and those will be distributed accordingly to all accounts. So you will start seeing some discounts as we use cloud more and more. Some common research use cases that we've seen on the commercial cloud, whether it's through the UBC Hybrid Cloud or directly with the commercial cloud, and would like to flag these options for you. ARC by no means are endorsing any of these services, but they are what we observe that other researchers have commonly used on the commercial clouds. So for example, as we kind of mentioned earlier in the presentation, commercial clouds are often used for hosting platforms, so data portals, web applications, anything where you may be collaborating with external collaborators. Remote desktops, so if you need more resources or more memory, more newer GPUs, for example, there are services like AWS have Amazon Lightsail for research, which makes it very easy to spin up a remote desktop in the cloud, and similarly with Microsoft Azure with the virtual machine service. In addition, all the machine learning artificial intelligence services became very popular in the last few years, including AWS Amazon SageMaker, Amazon Bedrock, Azure. They have very similar services, machine learning service, Azure AI services, such as OpenAI, Vision, and video indexers, for example. Database is also a very common service that is used. For example, AWS Amazon Relational Database Service and Microsoft Azure Databases on Azure. So one of the benefits of using these services is that you're not going to have to run your own virtual machines, so you don't have to apply the security updates and things like that yourself, because those are done by the cloud provider. So that's one of the benefits of using one of these database services. So I'll stop here for a pause here and see if anyone have any question about the commercial cloud, hybrid cloud service before I move forward.
Yes. Hi, thank you. Yeah. I have two questions. One is how much resources, is there any cap in terms of resources we can have from the commercial cloud? For example, in terms of number of GPUs, is there any cap?
I can answer that question in two ways, I guess. One is there's usually for every type of, let's use GPU as an example as pertain to your question, there usually is a cap that's available by default. But if you hit that cap, you and UBCIT could submit requests to increase that cap. So that's
I
an
see.
artificial cap. So that's the first one. The second is not necessarily a cap to how much we can use through the UBC Hybrid Cloud Service, but it is how much GPU is available at these data centers, for example. So as an example, certain researchers may have a requirement that they can only run their computation or machine learning models, things like that in Canada. So they're restricted to the regions in Canada. In that case, then if at certain time of the year, there might be a bigger demand for GPUs, there may be no more GPUs available. So in that sense, there are also a cap because there's a physical capacity that may have been met. So those are usually the two caps that we see researchers have hit. So the first one, as I mentioned, it's more of an artificial cap that can be requested to be raised. The second one, it's going to be a little bit more difficult. However, of course, if your research requirements is not as restrictive, you can use other regions, for example, then that does open up more capacity.
Yeah, thank you. So, how many regions in Canada does this is UBC EduCloud connected to? So Calgary, I think they opened like 1 year or 2 years ago. Yeah,
that's right. So UBC Hybrid Cloud has access to all the Canadian regions as they open up. So as you mentioned, Calgary recently opened up. So AWS, off the top of my head, there's one, Canada Central, that's been around for a very long time, and there's a new one as of a year or two ago from Calgary. Hypothetically, if a third region does open up, automatically UBC will have access to that as well. So UBC does not have a restriction on which Canadian regions you have access to. Is as these cloud providers open up more regions, they will be available through the hybrid cloud service.
Great, thank you. Another question is about the fee. And so I saw this from the commercial cloud providers, right? Once you sign up for 3 years or 5 years, they have a huge amount of discount.
Yes.
Yeah. Do we have this kind of service? For example, I sign up with UBC EduCloud for 3 years, and then do we
Yes.
have big discount?
Yes, there is that discount. So it is a service in per se that's offered by UBCIT. So when you request for the account, we will advise you that you mention it, that I would like to commit to 3 years of using these certain resources, GPU, CPU, whatever the case may be, and they'll work with you to submit that, to purchase that as a package, so that you will be charged at that discounted rate during those 3 or 5 years. And then at that time, you'll see all the what the cost would be, what the minimum requirements, things like that. Those will be discussed at the time.
Sounds great. Thank you.
Yeah. Thank you for the question. Let's move forward with the other cloud services that are available to UBC researchers, and I'll continue answering any questions that may come in. So UBC EduCloud. So UBC EduCloud is on premise, so it's on the Point Grey campus, and is a self-managed cloud service. So you gain access to the platform, to the tool, and then you deploy the virtual machines that you require. So it provides virtual machine storage, network, and resources, all the components and pieces you require to build the infrastructure that you need. Something to note, GPUs are not available for UBC EduCloud. However, so if you need GPUs, UBC EduCloud may not be the solution you're looking for, at least not as a major piece of the infrastructure. Being it's on premise, it keeps the data within institutional infrastructure, so it helps with the data residency requirements if you have that. Some of the operating systems that are available through this EduCloud service includes Red Hat, Ubuntu, Microsoft Windows Server, so that's available by default, and you can bring any other licensed operating systems to the platform as well. Something that may be useful to know. It's as well as that they have a backup retention policy of 90 days. So that directly maps to the risk management policy that's here at UBC for the 90 days. For more information on this service, feel free to access that link, and you can access for more information about what this service provides. So in terms of cost, there is, as we mentioned, there is a cost, but it is subsidized. So you won't see as high of a cost as you would through the commercial cloud. For this fiscal year that began on April 1st, a couple of weeks ago, you'll see that a VM costs $93. Each CPU that you allocate to that VM is $12. Each gigabyte of memory, $11, and then each gigabyte of storage that you allocate to this VM is 24 cents. And then you'll see that the prices are gradually increasing until the fiscal year 29 and 30. And the reason behind that is that the subsidy that is being applied to the service is gradually decreasing in the next 4 years. So put this to help make it a little bit more tangible and easier to understand for these costs. Here's an example. So if, for example, for a virtual machine that has 2 CPU, 8 gigabytes of memory, and 64 gigabyte of disk, a very typical VM for if you're running a very simple web application or a simple web data portal, it will cost about $220 today, this year, and this is a annual cost. And then it will, if you continue using this machine all the way to fiscal year 29-30, it'll be costing $336.68. And so that's the adding up all the costs in the table above. Okay, I see a question here. Any bandwidth limitation throttling caps when using the VM? There are some bandwidth limitations, and that could be based on physical limitations. And that's something, if you would be interested to find out exactly what that limitation are and that works with your workflow, I would suggest that you reach out to UBCIT, and they'll be able to provide a little bit more detailed answer to that. Yeah. So, and part of that is that they're also kind of redoing the UBC EduCloud service as we speak during this half of this year, where they are, I think, briefly, it was on the slide, briefly mentioned that they're moving to using OpenStack infrastructure from VMware. And as some of you may have heard about the VMware licenses. So with that, some of the infrastructure has sort of changed in the background. So they would be the best person to help address that bandwidth limitations questions. So with the changes to the infrastructure behind the scenes of this service, the UBCIT has introduced an automated operating system patching capability to the service. So it helps align all the virtual machines with the UBC's information security standards to keep all the virtual machines up to date and as secure as possible by reducing exposure to known vulnerabilities. So all the updates will include system security updates, system stability updates, and maintenance updates. It does not include any application software running on a virtual machine. So those will still be the user, your responsibility. But that also means that any of the updates that apply to applications, since they're not going to be automatically updated, you'll be able to control when they're updated to provide so that it be the least impact to your research projects. The automated patching happens on the 4th Sunday of each month at 1 a.m. The reboots will occur if any of the updates require a reboot for it to be to become active. However, if you don't want to avoid the reboot, or if you do apply the updates yourself before the 4th Sunday, you can do that, and then your virtual machines will be skipped and would not be touched, since all the security updates that would have been applied is already applied. Last but not least, if your research workload, your virtual machines are very sensitive to these automatic updates or reboots, there is a process to request for an exemption, and that's through the CISO office, UBCIT's CISO office, through the M1 policy for requesting what they call a variance. And that's so that's the end of UBC EduCloud. Does anyone have any questions before we move forward with the Digital Research Alliance of Canada? Yes.
Thank you, Michael. So I have one question. So if I have very sensitive healthcare data,
Yes.
clinical data, so which cloud do you recommend? Which one is more secure? EDU cloud or hybrid cloud? Or they're equal?
So they're both can be as secure as the other. The security aspects, they are comparable. I guess the main difference is the data residency, and there might be other compliance requirements. As I mentioned, if you do have something like a requirement that has to stay at UBC, then EduCloud may be your only option. However, and we'll touch on this in the at the end of this presentation on the privacy and security aspect of things, is that we also encourage you to reach out to ARC. We have a private research cybersecurity and compliance team and that's their specialty. They will be able to help you look at all your requirements to help advise you what you can do to be staying compliant, but also access the resources that you need to do your research. So and we'll get a little bit more details in the later slide, but what I'm trying to say is that commercial cloud may not be off the table. It depends on exactly your requirements, and potentially there are recommendations where you could configure certain things a certain way, and you still be able to use commercial cloud, for example, for your research that involves sensitive data.
I see. That's good to know. Thank you. Another question is, for example, if I host the data, everything on UBC EDU cloud, but I need a GPU, can I connect to the hybrid? Can I hybrid these two types of cloud?
In theory, yes. So that's where so first it'd be a good idea to mention that as you're requesting for access to these resources to the UBC IT team that are reviewing your request and potentially discussing with you what is possible and what potentially what limitations are. And that's also that's a great example actually of where using hybrid cloud instead of going to AWS, for example, yourself with your credit card, because hybrid cloud, the AWS, Azure environments are configured in a way that they can access resources that are on premise, which includes the UBC EduCloud.
Oh, that's very good to know. Thank you so much. So I can reach out to some solution architect to help me, right? Like
yes.
Yeah. Okay.
Yes. So they will review the tickets and then they'll bring in other experts, including AWS and Azure, if that's required. And that's part of where the support plans that are available through the hybrid cloud service as well.
That's great. Thank you so much. Yeah.
Thank you for your questions. So we'll go on to the last major cloud services that are available to UBC researchers, and that's through the Digital Research Alliance of Canada. So the Digital Research Alliance of Canada, or the Alliance, serves Canadian researchers with the objective of advancing Canada's position as a leader in the knowledge economy on the international stage by integrating, championing and funding the infrastructure and the activities required for advanced research computing, research data management, and research software. But today we'll focus more on the cloud aspect, but there are other services. So feel free to look onto the website for other resources that are available to Canadian researchers, including UBC. So through the Digital Research Alliance of Canada, or the Alliance, there are four what they call community cloud. There are on-premise at 4 different universities across the country. The largest being the Arbutus Cloud, that is located at the University of Victoria. So that is in BC, which may be beneficial for some researchers. And these clouds, as I mentioned at the beginning of this presentation, it's offered as an infrastructure as a service. So they provide you all the pieces that you may need to build your infrastructure, whether it's a data portal, web application, et cetera, et cetera. And just like UBC Edge Cloud, it runs on something called OpenStack. Just for your information, doesn't really impact how you use the cloud. So I'll go a little deeper into Arbutus Cloud, mainly because it had the newest hardware. It's been recently refreshed, funded by the federal government. It went live as of last week on April 7th. And some of the resources available include persistent resources. So those are the resources dedicated to running things that needs to be ran 24/7, so like a data portal. And also compute resources, which are more high memory or high core intensive. So those are very useful for if you would like to do testing your research analysis and things like that on a smaller scale before you scale up to the high performance computing clusters. The operating systems available for the Alliance Cloud include Linux, so various Linux operating system, and also Windows, which is coming soon. There are virtual GPUs available for the Arbutus Cloud. So for every Canadian researchers, they have access to at most one virtual machine with a GPU, and that's the first bullet point there, which has 12 gigabyte of GPU memory, free virtual CPUs, 35 gigabytes of memory, and 125 gigabyte ephemeral storage. If we need more machine than that or a larger sizes, so the second option, which has doubled the resources in a machine, that's available through the resource allocation competition, which runs every fall. So that runs annually every fall, so around the September to November timeframe. And ARC will have announcements regarding that. So does the Alliance themselves will also have announcements around that. So to access any of these resources, including other computational resources available through the Alliance, you'll first need an Alliance account. So seeing a link here, but I will provide a link later, but which is at a later slide. But you go to the Alliance website, you can register for an account. If you're a faculty member, you'll automatically register for an account. Once it's approved, you'll have access to the computational resources, and you also can apply for request for cloud resources. If you're a student, you would then be sponsored by your PI. Once you have access to an account, you can request access to any of the resources, including the cloud. In this example, in the screenshot, you'll just log in, select resources, access systems, select cloud. And then for the clouds that you need access to, for example, Arbutus Cloud, you just select I request access. And usually within 5 to 10 minutes, you will access to the cloud resources. The second step to accessing cloud resources is you need a project, what they call a project. So any PIs are eligible to request for what they call rapid access service. So it's like a small project with some resources for you to test your infrastructure and things like that, and to make sure it works. And if you need more, again, you can apply for the competition in the fall. So those are the limits that are available through the RAS, and in a lot of cases, actually, what we've seen is our researchers can do everything they need within these limits, so they don't need to go through, apply for the competition in the fall. So I'll quickly go over the form, but feel free to ask any question if you have any further questions about the form and how to request for a project. But essentially, you go to the form and you provide your username and then indicate that you're a PI. So for PI, this is again a RAS project. Only PIs are eligible, so you indicate you're a PI, and then you answer the subsequent questions, which I'll go over in 1 second. If you are a student and you're requesting access, or a postdoc, a graduate student, and you're requesting access to your PI's project, you'll select the third option here, access to an existing project. And then there'll be 2 or 3 more questions for you to answer, essentially helping you request for access to a specific project. So the first question that you'll have to answer is whether it's compute or persistent, and the difference is, as I mentioned before, so what you're trying to deploy something that needs to run 24/7, like a data portal, a data capture tool, something like that, or is it more computational? You're testing your high computation workload that requires lots of memory. So choose one or the other, and then that reflects the limits that you have access to and the virtual machines that you have access to. Then we will ask you a little bit of what you're trying to achieve with these resources. Why you need cloud resources, and why the HPC clusters are not suitable for your needs. So typically, we see what researchers need cloud resources for are things like they need something that is 24/7, like a database or a data portal or some test bed for their analysis where the HPC cluster is not suitable. So you'll provide that justification and your use case in these questions. A question about how you'll use it efficiently. Essentially, it basically is trying to gauge how you will manage these resources because it is a shared resources across the country. So how you're going to manage these resources effectively. So something like for the computational, the high memory, lots of resources. We'll ask researchers to potentially shut those virtual machines down when you don't need it, instead of running them for a long period of time when not required. Of course, again, back to the data portal example, you can run those 24/7, and that is totally a practical example of how you'll use something for 24/7. And a quick question about maintenance, security, upkeep. What is your plan on keeping these virtual machines secure? Whether you're applying these security updates monthly, not sharing passwords, things like that. I'll gloss over this a little bit, but essentially all these questions that you see here are really asking how much resources you need. You don't necessarily need to ask for the maximum for the RAS project requires. In a lot of cases, you don't need that, and then you will be asked for more justification for what you're requesting for the maximum. But this form is essentially asks how much you need, and if you need more, let's say 6 months later, you can always submit another ticket to request for increases to those quotas. So once you have access to a project, you'll see the home screen here, and this is where you see all the resource quotas that you have access to, and this is to help you better manage your resources. So for example, memory, how much memory do you have left that you can allocate to your virtual machines, for example. I'll go over very quickly on the storage available through the Alliance Cloud. Volume storage, that's very typical storage that you think of for virtual machines. So they're persistent. They're usually the storage that you use to store data persistently for data portals, things like that. Ephemeral disk storage, these are the storage that comes with the memory intensive, high memory virtual machines for computational purposes, and these storage is not intended for keeping data long term. They're only intended to store data for when you need to do the computation, because once you shut down the machine, all the data will be gone from that storage. Object storage, very typical storage to be used for as to back up certain web applications that are designed to use S3 compatible storage, also for archival purposes. Share file system storage. There are use cases where researchers need a storage that can be accessed by multiple virtual machines, and that's one of the use cases for a share file system storage. Very quickly about floating IP, or essentially an address for your virtual machine so that they can be accessed on the worldwide, not necessarily the World Wide Web, but you can access it publicly. Obviously, you want to restrain where you can access these virtual machines, but floating IPs are the mechanism that you need to assign to a virtual machine to help you and your lab to access these resources. Snapshots. Snapshots is a concept within the Lions Cloud. It includes the operating system, all the configuration and data. Some of the use cases to using snapshots is to help you migrate instances to another cloud, as we mentioned, just within the Lions cloud infrastructure. There are 4 clouds across the country. So if you, for any reason, need to move your virtual machine from, let's say, from Quebec, there's a cloud in Quebec, and you need to move it to BC, to Arbutus, this is one of the ways you can do that through a snapshot. And to also back up a virtual machine you configure perfectly. So if you have to launch a lot of the same machines, and there are use cases for that, sometimes you will want to configure it one perfectly and take a snapshot so that you have the perfect template to spin up other virtual machines in the future. And a recommendation for taking a snapshot is to shut off the virtual machine first before taking the snapshots. Security groups. So this is to help you to help maintain security of the Lions Cloud for your virtual machine. So I quickly mentioned about the floating IP, which you use to access, so you can access it from, let's say, your at home, from your research lab, etc. But for best practices, you likely would like to restrict access to only specific places, such as your research lab from home. So security groups is the mechanism you'll use to restrict, for example, SSH access or web access. And this is the mechanism you use to protect your virtual machine. Last but not least, SSH keys. So the Alliance Cloud for best practices, do not use username and password to access a virtual machine. They use SSH keys. So this is where you manage SSH keys so that you can access the virtual machines. And there are instructions on how to add additional SSH keys so that multiple research team members can access the same virtual machines with, and apply the same best practice where you're not sharing SSH keys. And to add on to what the Alliance provides, there's a database as a service available through various multiple clouds across the country, and essentially that provides you access to a MySQL or Postgres database, and you just need to request for it. And benefit of doing that is that you don't need to maintain the database infrastructure itself. You don't need to apply the security updates, etc. You'll just be using the database on top, and everything else will be managed by the support teams at the various clouds. Last but not least, I believe, yes, last but not least, Nextcloud. So Nextcloud is like a Dropbox-like cloud storage service. So it's available to store data and also to share data, documents, etc. with your collaborators. Available to all Alliance users. Every user gets 100 gigabytes, and it's accessible from web browser. There's a desktop app to help you sync the files between Nextcloud and your computer. There's a mobile app, and you also can access through the command line tool. It can also be mounted to your computer. And sharing is available through all these other groups that's listed there. Alliance users, CCDB group name, so that's something that's a concept within the Alliance, where a research lab, for example, and non-Alliance users. And so this is just a screenshot of what it looks like on Nextcloud. You'll see it's very Dropbox-like. Next is best practices. So I'll go over the best practices, and then I'll open up for any further questions that you may have. So to help sort of to address the question that we had before, privacy and security. So some things to consider to maintain the highest level of security for your virtual machines is to confirm the security settings are appropriate to the data you wish to store, process, or transmit through the cloud service. So the more sensitive the data is, there are more things to consider when you're configuring your virtual machine. a great example being like the security. You may want to restrict where you can access these virtual machines. A privacy impact assessment. So privacy impact assessment is an assessment that is required by more and more reviewers where they assess the tool they're using, whether it's a cloud or on-premise. And so they assess, and something to note is that even if another researcher has completed a PIA for the same cloud service, you may still need to request for a PIA because your situation may not be identical to the other researchers. However, if another PIA has already been completed, you do get a faster review because the reviewers have already seen the application before. And then there's a link here to access some of the approved PIAs that are now publicly available. And if you have more questions about the PIA process or more information about this process at UBC, you can go to the Privacy Matters website, and you do need a CWL to access this information. Second, security threat and risk assessment. That's also something that may also be required depending on the solution and depending on your compliance requirements. So this is actually done for research. Often is being reviewed and done here at ARC with our research cybersecurity and compliance team. So if you have any questions, feel free to contact us. We'll have our contact information at the end of this presentation. And essentially is assessing all the security aspect of your application or multiple tools that you're linking together and how the data is transferred from one to the other. And they'll also provide some recommendation how you can improve the security and also be in more compliance. So actually, you need to go to the end of the slide. So if you require consultation or have questions about the STRA, for example, feel free to reach out to our RCC team at arc.support@ubc.ca. And for more information with some more research specific about these processes, you can go to our website as well and security and privacy. And I think I have one more slide and then we can open up for questions. So last but not least, for privacy and security, some basics that includes security updates. So we want to do that on a regular basis, monthly, bi-monthly, in terms of keep your virtual machine secure. And as a note, EduCloud, there is an automated patching system. So that you may not need to do it yourself and leave that with the service providers. And with that, I can open up the floor for a couple of questions, and then I'll end this presentation.
Sorry, I have another question.
No.
Asking too much. Yeah. So I saw this is part of the ARC infrastructure, the team entirely, or for example, if I call ARC endpoint from the EduCloud, would that be possible? For example, I use ARC. I have orchestration on the EduCloud, and then I call the resources from ARC. Is that possible?
If ARC, are you referring to our computation Sockeye?
Yeah, Sockeye.
At this time, I don't think it's possible. In this case, I would recommend you to submit a ticket to also arc.support, the email address I shared earlier, and then we'll have my colleagues that can help answer this question more in depth, what's possible, what isn't. But yeah, so maybe I'll leave it at that just so, yeah.
Okay.
Yeah.
Sure. I have maybe sort of unrelated questions. Do we have UBC local large language models available for us to some large language models deployed on premises?
At this time, we don't. But I would suggest look out for announcements in the coming years because the university is working on this so that we can find a balance between having access to these models, to these tools without sacrificing the security aspect or the privacy aspect. So I would recommend look out for the announcements because the
Okay.
university is definitely working in that direction.
Okay, sounds great. Thank you.
So related to that, maybe I can come here. So I'll quickly go over the resources available, and as everyone can access the slide deck. Now provide the slide deck very soon. Here, these are the a website and also contact information to ARC, so you can contact us for anything that is general questions about how we can use these resources with your research project, all the way to if it's something specific to ARC services, or as I mentioned about the security threat risk assessment or PIA. If you have questions about that in regards to your research project, feel free to contact us at this one email address, arcsupport@ubc.ca, and your questions will be triaged to the right persons that can answer your question. In addition, here's some links to the some of them I've shared in earlier slides for UBC Hybrid Cloud, UBC EduCloud, and more for the Alliance Cloud as well. And last but not least, we'll greatly appreciate if everyone could answer this 5-question survey to help us give us feedback on how we can improve, what other what we can improve on, what kind of topics per se, what you would like to see. And as a thank you, all survey participants can enter a draw to win a bag of ARC swag. The draw will happen at the last week of April, end of this month, and then you'll be notified by email. And with that, we do have another 5 minutes before we are at the hour. So if you have any questions, feel free to put in the chat, Q&A, or you can unmute your mic.